Okay, so here's a supplemental video for section 6.4 in geometry on rectangles. It's funny, I actually printed this out from the textbook, and they have a typo in there. It's not. Luckily, the book didn't have a typo, but the worksheet does. So we're talking about rectangles, and the actual definition for a rectangle is a parallelogram with 4 right angles. The book did a weird thing in this sheet and put quadrilateral, but that's not the technical definition. The technical definition that I'll be testing you on, you need to know, is that a rectangle is a parallelogram with 4 right angles. And we define it that way on purpose, right here. A rectangle is parallel. The sides are all going to always be parallel, because once you have 4 right angles, it gives you consecutive angles that are supplementary for all 4 groups of angles, or opposite angles that are congruent, however you want to think of it. It makes it a parallelogram, though. But instead of us proving it every single time, we just define it that way. And the reason we do that is those properties we had from a parallelogram, and they've cut only part of these here, but opposite sides are parallel, that's given. Opposite angles congruent, opposite sides congruent, consecutive angles supplementary, diagonals bisect each other. Those are the big 4. But we also get, hey, one diagonal cuts it into 2 congruent triangles. And we also get, if you have 1 right angle, you have 4, which in this case you do because that's the definition. So that is those are the big properties we got from a parallelogram to begin with. Now we get to use them with rectangles. Secondly, we talked about in class today that there are, aside from the definition, 4 right angles in a rectangle, there's one theorem, really specifically one theorem in the entire chapter, and that is that the diagonals are congruent for a rectangle. So segment TR and SU are congruent. Now that doesn't work for all parallelograms, just for the rectangle, because here's a just kind of generic Mr. Moyer poor attempted drawing diagonal or parallelogram, and this diagonal here is not as long as this guy is. This one's clearly, hopefully you can see it by even my poor drawing aside, clearly longer this distance than this one is. But if it's a rectangle, those guys are the exact same length. So homework kind of amounts to 2 types of problems. One type is, hey, here's some stuff about a rectangle. You know, you got the diagonals. Solve for x. Okay, well, you know, I know RT and US are congruent, so set those equal to solve for x, because they're the diagonals. All right, set those up. Set them equal to each other, we solve, we get x is 5. Okay. Other question that's specific to a rectangle would be, hey, it's a rectangle, solve for some angles. Well, we know that, you know, in this case here, find the measure of STR. Well, STR is this guy right here. So he is part of the bigger angle that's a right angle, so STR and UTR have to add up to be 90 degrees together because they make a right angle. Set them equal, solve for x, and then plug that x back in. We get x is 4, and then we plug 4 back in for for angle STR, which is 8 times 4 plus 3. Well, 8 times 4 plus 3 is 35. So the homework problems, a lot of them essentially amount to, hey, it's a rectangle. You got opposite congruent angles that are right angles. You've also got diagonals being congruent to each other. The second type of problem, this is the one that's probably going to cause more difficulty, is proving that something is a parallelogram. Proving something is a rectangle. And there are 2 ways to do this. The first way is to kind of go by the definition, and that's using the slope formula. So if you plot out the 4 points they've got here, negative 3, 0, negative 2, 3, 4, 1, and 3, negative 2. You plot it out, you get this shape here. It looks like a rectangle. So there are 2 ways to prove that. One is to show that the opposite sides are parallel, which we do the slope formula. Hey, 3 and 3, those guys are parallel. Negative 1 third, negative 1 third, those guys are parallel. There are my 2 opposite angles that are sides that are parallel. That makes it a parallelogram. The next question is, does it have 4 right angles? Well, it does, because these sides are perpendicular. The slope here is 3 over 1. Here's its opposite reciprocal, negative 1 third. It's got to be a rectangle then, because that means that all 4 of these angles are right angles. The other way to do it, and this is actually the quicker way, believe it or not, is to not use the opposite sides being congruent like they've done up here. Actually, we can skip this, because one of our theorems is if it's a quadrilateral with or a parallelogram with congruent diagonals, it's a rectangle. Well, we would know that from doing the slopes already, that it's going to be a parallelogram. The next easiest thing to do is this. Hey, let's show that the diagonals are congruent. So it makes it a lot easier if you just say, okay, let's see what BD's length is, let's see what AC's length is. In this case, they're both root 50. There we go, parallelogram and rectangle. Okay. So there are two ways to do this. One is to find the slope of all four sides. If you do that, you're really pretty much done. You've shown that you've got not only do you have parallelogram, but you also have perpendicular sides by the opposite reciprocal slopes. Or you could do the distance formula, show that both pairs of opposite sides are congruent, and then show that the diagonals are congruent as well. So here's some homework, a couple problems to look at. First one is a proof. Number 20. The question is to prove that, or given that ABCD is a rectangle, prove that triangle ADC is congruent to triangle BCD. Now, what might make it easier is to sketch out the two triangles we're trying to prove. So here's ADC, okay, and here is BCD. I just pulled ADC down here and BCD down here. Now, there are a lot of ways to go about doing this. Actually, we don't even have to even use the fact that it's a rectangle. We really could just, if we knew it was a parallelogram, we could do that if it were a parallelogram. But we can get around that in this case by just saying, okay, let's use the definition of rectangle. And by doing that, first of all, it means it is a parallelogram, which is important for us because that means that AD is congruent to BC. Here's AD, here's BC, because opposite sides are congruent. Once we have that, we also have a pair of congruent sides in DC by reflexive property. DC is congruent to itself. So that's our second part. Now the third part, and this is the only part that really uses it being a rectangle, is we can get the third pair of sides, which are the hypotenuses, BD and AC congruent, because they are the diagonals. AC is one diagonal, BC is another diagonal, and for a rectangle, the diagonals are congruent. So there we go. And now that gives us side, side, side. So statements and reasons. One, ABCD is a rectangle. Given. Step 2, I'm going to go in the order I kind of marked it out. AD is congruent to BC. If it's a parallelogram, which it is because it's a rectangle, opposite sides are congruent. Okay. Step 3 then was DC is congruent to itself. That was the second pair we talked about being congruent by reflexive property. Step 4, this is the part that comes into the rectangle. AC is congruent to BD. Okay. And if, sorry, it's so sloppy. If it's a rectangle, then the diagonals are congruent. If rectangle, diagonals are congruent. And number 5 then, now we're ready to stay for that last step. Triangle ADC is congruent to triangle BCD by side, side, side. So there we go. Okay, so just to summarize real quick, I know this video is getting long, but just to summarize real quick, we talked about the two triangles, drew them out. We knew the opposite sides were congruent because it's a parallelogram, so opposite sides are congruent. We also knew DC was congruent to itself because they overlapped and had side DC together. And we knew because it was a rectangle, AC and DB have to be congruent because AC and DB are the diagonals of the parallel or of the rectangle. And then by that gives us side, side, side that the two triangles are congruent. Okay. The last problem I want to look at, and I'm just going to look at part of it. I'm not going to do all of it just because this is getting already to 10 minutes. Is number 24 in the homework, proving that you have a rectangle using the distance formula. So I'm going to plot the points out, and I'm just going to have to make an approximation for 6, 1 because it doesn't fit my grid that I've got here, but it's good enough. So negative 2, 2. There's point Q. R is 0, negative 2. S is over 6, up 1, so it looks like it'd be somewhere around here. And then T is 4, 5. Now what I'm really doing is this problem here from that I looked at earlier. I'm going to prove that this is a rectangle using the distance formula. So the part I'm going to skip just because of time is proving that the four sides, both pairs of opposite sides are congruent. They are. You just do the distance formula for both of those. All I'm going to work on is the part that's really new. Hey, how would I prove that this is a rectangle? Well, I have to do this extra stuff of proving that the diagonals are congruent. Because again, it said use the distance formula. If it said use the slope formula, I'd go back and do what was up here. But it said nope, distance formula, so I'll do this part here. So I'm going to skip this first part for this problem. You need to work those out to get your opposite sides being congruent. Now I'll then use the diagonals congruent. So in our case, our two diagonals are QS and RT. So distance formula is x minus x, or x minus x squared plus y minus y squared. So for QS, it's negative 2 minus 6. And then y minus y is 2 minus 1. That's going to give us negative 8 squared plus 1 squared. Well, negative 8 is 64, and I square it because it's negative 8 times negative 8. 1 squared is 1. So root 65. Now I'll do the same thing with TR, and I'm going to get root 65 again unless I messed up somewhere. We'll find that out together. So 0 minus 4 squared plus y minus y, which is negative 2 minus 5 squared. So 0 minus 4 is negative 4. I'll have to square that. Negative 2 minus 5 is negative 7 squared. And again, I keep putting these parentheses in here because I've got to remember, when I square a negative 4, it's negative 4 times negative 4, which is 16. When I square negative 7, it's negative 7 times negative 7, which is 49. It's positive. And some of you guys keep making that mistake when you do the distance formula. You're just throwing it into your calculator blindly without parentheses, and it does negative 4 squared. It tells you it's negative 16. Well, when there are no parentheses, it does mean it's negative. But in this case, there are, so I have to square it. Either way, I get back to root 65. Root 65 and root 65. Hey, it checks out. Diagonals are congruent. There we go. So that's the video for section 6.5.